Hello, hello. Can you hear me?
Can hear.
Okay. Okay, you can see the textbook. So yesterday 3.5 finish, huh? Okay, so we continue. Okay, you can see the digital textbook.
Can see.
Okay. Only Daniel will answer me, I think so. Okay, so today index, the area under a curve, huh? Okay, this is today index. Today 16. Use max 3. Okay, so same thing. This Friday, I will see you from 12 to 12:30. Okay. Actually, for those saying you all have tuition or whatever is, I mean, is not right lah, because it's written a tutorial. Okay, I mean a lesson for me. Okay, at that time, you know. Then how about when school open? How you want to have a tuition at during that time? I understand that maybe some of you, 12:30 got Tamil class lah. But the rest saying that you got tuition, no, from 12 to 12:30, that is I can't accept it lah. Okay, so let us continue. Okay, first of all, we want to investigate the relation between, okay, the limit of the sum of area of rectangle and the area under the curve. Okay, I'm going to show you this link. You. Okay, so you see this. Okay, we go back to the textbook. Okay, let n be the number of rectangle under the curve. Okay, so this one after I will make the n become bigger and bigger lah. Okay, means the number of rectangle under the curve I want to make it more rectangle, means I cut the rectangle become become a smaller, okay, so that I will get a more number of a rectangle. Okay, so we want to see, okay, when the number of rectangle become more and more, actually your answer for the uh, area of all the rectangle, okay, will be very very near to the area under the curve. Okay, this is what we want to see. Okay, drag the cursor end from the left to the right, okay, to increase the number of the of the rectangle. Notice the area of a region under the curve are y equals to negative x squared plus 6x as n changes. Okay, copy and complete the table below. Okay, so number of rectangle n, okay, it start from the one, okay, only one rectangle, okay, and then this link, okay, they make it until 20 lah, okay. If you can make more than 20, you actually can see the answer is even nearer to the exact answer, the actual answer. Okay, area of the region under the actual curve, okay, you see here, we come back here, area of the region under the actual curve is 36, means this curve, okay, this is 36. Okay, then we want to see afterwards from this 54 it will go near and near and near to 36 okay, wait okay, we come back here. Okay, sum of the area of the rectangle under the curve, okay, means the rectangles you find the area and then add it up, sum, okay, add it up. Okay, so okay, so we start with this one whole area, this one whole area, the rectangle. Can you see a rectangle? Okay, can see the cursor, the mouse cursor? Genia, can see the mouse
Yes,
cursor?
can see.
Yes, okay, so you see this is a rectangle. Never mind lah, I only talk to Genia. Okay, the rest I don't know here or not. Okay, so from here to here, this is the, how to say, the width of the rectangle. So here to here is 6 unit. Okay, and then the length of the rectangle is 9 unit. Okay, so 6 by 9 is 54. Okay, so this one is for one rectangle. Okay, we want to compare this one rectangle with the area under the curve, area under the curve, okay, 36. You see lah, okay, confirm this the, how to say, the rectangle, the area is more than the 36 because this area okay. So now we drag this number of rectangle, okay, now become two rectangle, okay, it's still the same, okay, it's still the same, okay, now become three rectangle, can see or not? When become three rectangle, they can smaller this one, they can make this side smaller, they can cut away this and cut away this. Okay, so now you see, just now is 54, now become 50. Okay, how you get the 50? You get this, the first rectangle, the area, second rectangle, the area, the third rectangle, the area, and then add it up, so you get 50. Okay, so you see just now from 54 it become 50. When the n become bigger, means the number of rectangle become more, okay, you will see the area of the sum of all these rectangle is become closer to the actual area under the curve. Okay, now increase some more. Okay, now become 4 already. Can see or not? Just now this one, it cut even bigger. Okay, so now you see just now from 50 it become 47, even nearer to 36. Okay, we go some more. Now become 5. Okay, so you see 47 become 45, even nearer to 36. Okay, and then continue, 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 continue. Oh, this is very good. Okay, you see this one how they make. Okay, I don't know how many rectangle already. Okay, I know I drag until the end. This is 20 rectangle. Okay, you can count and see lah. I'm lazy to count lah. Okay, this is 20 rectangle. So you can see the extra all this one become smaller and smaller. Therefore, you see the the sum of the the area of the rectangle, 39 is very near to 36 already. So you can imagine actually if you increase some more, means more than the 20, become very small, very tiny, of your rectangle, actually you can find, okay, and then use the concept of limit, you can find the area under the curve which is very close to it. Okay, so this is the idea of the limit lah. Okay, so we go back to the textbook. Okay, this is a conclusion for it. Chili. This is the idea of it. Okay, they cut, you see just now that one they cut, the rectangle is a bit more higher than, a bit more than the area under the curve. But for this example, you see the way they cut, a bit smaller. Okay, actually both way also no problem. Okay, the idea is the same thing. Okay, so this one I don't want to go through in detail. Okay, so we straight away go to here. Okay, so they say that, if you add up all the area of the rectangle, okay, your answer will be very near to the area under the curve. Okay, so for a rectangle, how to find the area of a rectangle? Okay, you see here, you look at this. Okay, how to find the area of the rectangle? Okay, they are using the a small strip of the rectangle, as an example. So this one is the length. Okay, the length we compare to this, the length is the y. Okay, the length is y, and then here is a width. Okay, width is in the x direction. If this is very small, we put it a del x. Okay, del x. So it will be y times del x. So y times del x. Okay, y times del x. Okay, this is the idea. Therefore, you can write it as a symbol of integrations. Okay, y dx. Okay, the y dx is actually revolve from here, y del x. Okay, then the y del x, it come from where? Because this is the formula area of a rectangle. Okay, so y del x. Okay, the y is in this direction. Okay, and then the x is in this direction. And then we want to make the x is very small. That's why we put a del x. Okay, so this is how we get this formula. Okay, so you remember area under the curve. Area under the curve. Okay, area under the curve. Okay, is this. Again, there is no formula given, no. Okay, so you have to know this. Okay, for the old syllabus, this formula actually is given. Okay, but for you, non-formula is given in this chapter lah. So all this, you have to know how it come from. Okay, so that you don't have to memorize by heart. Okay, so you will know how what is the formula should be. Okay, to get the area under the curve. Okay, this is how we get, okay, this formula. Okay, now we start by using this formula to find the area under a curve. Okay. Okay, so we start with this. Okay, area of a region. There are three, Okay, we go through very fast. Area of a region. Okay, so the first one is area of a region between the curve and the x-axis. Okay, between the curve and the x-axis. Okay, the limit A and the B is here. Okay, B is upper limit, A is lower limit. Okay, this is the area in mention. Okay, the A. Okay, so we can find this area, okay, by using this. Okay, this is the first one. Okay, we go through very fast first about the formula. Okay. This is the second one. Okay, just now it's between the curve and the x-axis. Now it's between the curve and the y-axis. So between the curve and the y-axis. Okay, so the limits is here. Okay, so this is the area dimension. Okay, so this is the formula. Okay, just now the formula is y dx. Now the formula is x dy. Okay, so after that, we will see how we apply all this. Okay, this is second one. One. Okay, area between the curve and a straight line. Okay, this is an example. A curve and a straight line. Okay, area between. So you're using this. Okay. Okay, this is another one. Okay, curve and the straight line. So that's all for the area. Okay. Come back to the first one. Okay, we come back to the first one. Ready? Okay, the diagram on the right show a region bounded by the curve. Okay, y equal to fx, the x-axis, and the line x equal to a, x equal to b. Okay, this is the line x equal to a. This line we call it x equal to a, and this line we call it x equals to b. Okay, the formula of the area of the regions, area of the region A is given by this. Okay, so remember, if the 2 point here, if the two limits here, okay, is from the x-axis, then here is dx. This is how I remember. Okay, if here is dx, make sure this 2 point is from the x-axis. Okay, so afterwards, when you see between the curve and the y-axis, area between the curve and the y-axis, this 2 point is from the y-axis, and then here is dy. So it will be x dy. This is how you remember the difference in between these two. Okay. So before we see into it, maybe I can show you one example first. Okay, we skip the sign first. We look at this. We look at this example first. Okay, find the area of each shared region. Okay, so you see the curve. Okay, the x-axis. I draw again. The curve, the x-axis, bounded by x equal to 6 and x equal to 3. Okay, this 6 and 3 you take from x-axis, right? Okay, 6 and 3. Here is dx. Okay, what dx? Y dx. If here is dy, then it's x dy. Okay, if here is dx, means it's y dx. Okay, so you write out the integration. Okay, this one is the area, okay, formula. Okay, next, what is y? You can't integrate y with respect to x though. Okay, what is y? You got to write the y in terms of the x. Okay, write the y in terms of x. Only you can start your integration. So what is y? Now, it's here. Okay, y is equal to 2x squared. Okay, so write the y as the 2x squared. Okay, only here you can start your integration. Okay, so how to integrate? Okay, 2 you write back. Okay, x squared. Okay, the 2 power 2 plus 1, so it's power 3 over the new power, which is 3. Okay, then put in your limit 6, 3. Okay, then substitute. Okay, minus, then you get the answer 126. Okay, so this is how you use the formula to get the area, okay, under the curve. We look at this. Okay, again, I will go to this website. Okay, this is the one. Okay, we want to see actually this one. Okay, when you have the area above the x-axis and the area below the x-axis. Okay, what is the difference? Okay, so observe the area under the curve. Okay, which is displayed on the plan. Drag point A to 0, point B to 5. Okay, so I follow the step number 3. This one I drag to 0. Okay, then this one I drag to 5. Okay, so here you see this is 0 and this is 5. Okay, I can label it also 0 0. Okay, 5 0. Okay, then you see the integration. Okay, the integration give you 52 point something. Okay, next. Okay, take notes of the locations of the area from, okay, with its corresponding sign of the value of the area. Okay, so this area, okay, the shaded one, okay, it formed actually above the x-axis. The locations are, location is above the x-axis, then the integral, okay, this one, the integral is a positive 52. Okay, next, I want to make this become negative 5. Okay, negative 5. Okay, and then I want to make this one 0. 0. Okay, now you see the shaded area. Okay, now this area is below the x-axis, and then you can see just now the integral. Okay, the positive become the negative. Okay, this is just a very simple activity. They just want you to show. They just want to show you that, okay, if the area is if the region is above the x-axis, the integral that you get is positive. If the regions is below the x-axis, the integral that you get is negative. Okay, so we come back here. Okay, we look at these conclusions. Okay, so this is very important. This one you should write in your notes. Okay, integral value is positive, integral value is negative. Okay, this one also you copy into your book. Okay, for the value of the area bounded by the curve and the x-axis, if the region is above the x-axis, then the integral value is negative. If the region is above the x-axis, then the integral value is positive. Okay, the area of both regions are positive. When the question asks for the area, when you get the integral is negative, although you got to write the last sentence, okay, say this is positive for the area. Okay, we will see one example. Look at this example. Okay, just now the example A, the area, this area is above the x-axis. Therefore, the integral confirm. You will get positive, no doubt. Okay, this one you get positive. Okay, no doubt. Okay, but here, for the B, for this one, you see the area is, the regions that you want to find is below the x-axis. Okay, so for this, the integral afterwards, when you get, your answer is in negative. But because the question asking for area, so last one statement, last one sentence, you got to write back in positive. Okay, we see how we do. Okay, so the area is equal to the integral, okay, from 5 to 2. Here is 2, here is 5. Okay, from 2 to 5, sorry. Okay, from 2 to 5. Okay, then y dx. Okay, why is y dx, not x dy? Because the two value I take from the x-axis, so x-axis here is dx, so it's y dx. Okay, continue. Okay, what is the y? I can't integrate y with respect to x. I got to change the y in terms of the x. So y is this. Okay, so I write as x squared minus 6x plus 5. Okay, dx. Okay, integrate this. So the power up over 3, sorry, minus 6. Okay, 2 over 2, 5x. 5, 2. Okay, this one cut. Okay, so I get this. Okay, then substitute. 3x squared. 5. Okay, minus. Let's substitute 2. Okay, then get the answer. Okay, I straight away get the answer. Okay, I get negative 9. Okay, I get negative 9. Okay, but remember, area cannot have negative. Therefore, you need to write the last sentence. Okay, area equals to 9. Okay. This concept is very important. Okay, the concept, the questions on the conceptual problems, always they will ask in the paper 1. Okay, so you remember, okay, if the regions shown is below the x-axis, the integral you will get negative. But when the question they ask for area, then you have to state it in positive. Okay, the negative sign of the value of the definite integral is only used to indicate that the area is under the x-axis. Hence, the negative sign can be ignored for its area. Okay, so you see this. Okay, this negative sign, but meaning one, no? Okay, is to indicate that the area is under the x-axis. Okay. Okay, so we want to see more example. Okay, look at this example. It combines, okay, there is a region that above the x-axis. Also, there is a region that below x-axis. So this example is very important. Okay, maybe you want to copy in your books also. Okay, the diagram on the right show a parts of a curve. Okay, find the area of the shared regions. Okay, therefore you see here. Okay, this part from here to here. Okay, this part is below the x-axis, and then from here to here, I use another color. Okay, from here to here, this is above the x-axis. Okay, so separate into two lah. Okay, you got to separate the integration. You cannot one shot from the 0 to 6 cannot. Then you cannot get the answer. Okay, because these two give you different sign. Okay, so you got to separate the integration from 0 to 3, then the other one from 3 to 6. And then for the 0 to 3 one, remember to change it become positive before you plus with the 3 to 6 one. Okay. Okay, let A be the area of shadowed region below the x-axis, B the area of the shadowed region above the x-axis. Okay, so you see, you find one by one. Okay, then here when you get negative, remember to turn it to positive before you add to the area B. Okay, so you see, this is 45. Okay, 9 plus 45. They don't use negative 9 to plus 45. If you use negative 9 plus 45, then your answer is wrong already. So remember, when before you plus, you got to change the negative 9 to 9 first. Okay? Okay, so we see, okay, it's from 0 to 3, same thing, the y dx. Okay, the y is 2x squared minus 6x. Okay, then you do the integration, substitute in, okay, you get negative 9. So remember to change negative 9 to 9. Okay, then for region B, you do the same thing, but the limit is from 3 to 6. Okay, the integration all are the same. Okay, then after that, you substitute the upper and the lower limit, you get 45. Okay, last step, you just get the 9 plus 45, you get 54. Okay, another way of doing, you can one shot, okay, but put a modulus for it because you already know the sign of this integral because the region is below the x-axis. You confirm, you know already this one sure will come out with negative. Okay, so you put a modulus for it. Okay, then you will change it to positive. Okay, then you get the same answer. Okay, so remember these questions you cannot do this way. 0 to 6 cannot one shot, cannot. Okay, so maybe you want to write some notes for it. And then this how to say, this subtopic, the exercise is very a few questions only in your textbook. So afterwards, I will how leh? Mm, mm. Is that okay? I snap photo. Then can you print out or what? Let us discuss this. Any idea? I want to take some question from other books, but all are picture. So I don't want you to draw. It's wasting your time if you draw it. So, but I want you maybe, to print out, and then, you can cut one by one the picture and then paste it in your exercise book and then do. So how do I send you the questions? Any idea? The easier way for you and also the easier way for me, maybe. The easier way for me will be, from my handphone, I snap photo and then through your WhatsApp. Is it okay? Monitor, Vanessa here. Eh? Vanessa not here? Farah not here? Dashna not here? Your monitor, Vanessa also not here. I don't know. 19 minus me, myself, minus Chong, 17. 5 not here. My goodness. Hema. Hema, oh. Sirania.
Yes, sir.
Okay, how? Is it okay?
Just send in WhatsApp, sir.
Can, then you all can print out, Huh? Cannot hear you. Yes or no? Siranya.
Teacher, she said yes.
Oh, she said yes. Okay, thank you. Okay, so no problem. I will send you through WhatsApp and then you do. Okay. I think I can go a little bit more. Okay. The second one. Okay, in between the curve and the y-axis. Okay. Okay, so this is the one between the curve and the y-axis. Okay, so the diagram on the right shows a region between the curve and the y-axis bounded by the line y equal to a, y equal to b. Okay, so this line is the y equal to b. Okay, this line is the y equal to a. Okay, so this is the area. Okay, so remember, if the two point you take from the y-axis, you see the a and b you take from the y-axis, here is dy. Okay, what dy? X dy. Okay, so again, same thing. This one you should write in your notes. Okay, so same. This one we skip first. We look at one example first. And, okay, we look at B. Okay, how we want to use just now that formula to do the questions. Let's see. Okay, first of all, I don't know this. Oh, I don't know this. Okay, so I need to find these 2 points. Okay, so this is the y-intercept. So I have to let the x become 0. Okay, so I let the x become 0, then this one will get negative y plus 1, y minus 3 equals to 0. Okay, the negative move to this side. Okay, negative 0 is still 0. Okay, therefore, y is negative 1, and then y is 3. Therefore, this is 3 and this is negative 1. Okay, so my integration will be from negative 1 to 3. Okay, because this is taking from the y, so it should be dy, and then here is x. Okay, same thing like just now. I cannot integrate x with respect to y. I got to change this x in terms of y. Okay, in terms of y. Okay, change the x here in terms of y. How to change the x here in terms of y? Nah, it's here. X is equal to this. Okay, so replace the x with this whole thing. Okay, next. Okay, I cannot integrate this. I got to expand this. Okay, so the expansion, I will do it here. Plus 1 minus 3, minus 2. Okay, so negative, positive, positive. Okay, so the integration now become this. Okay, this is before you integrate it. Okay, so after you integrate, you put this. Okay, so 3 over 3, 2 over 2, 3y. Now, you can integrate y with respect to y, but you cannot integrate x with respect to y. Okay, so continue. This one cut. Okay, so you do the substitution. This one I don't continue already lah. We straight away look at the answer. Okay, we straight away look at the answer. Same thing, same thing. Okay, after you substitute, this is the answer that you get. Okay. We come back here. Okay, same as just now. Okay, one is positive and one is negative. So I'm going to show you again this link, the other link actually. Okay, same thing. Okay, first of all, I drag the A becomes 0. Okay, then the B become 5. Y equal to 5. Okay, so this one, you see the integral here is positive. Okay, then you notice that the area here is on the right. Okay, on the right of the of the y-axis. Okay, now, okay, this A, I make it become -5. Okay, then the B, I make it become 0. Okay, so now you see the area is on the left of the y-axis, and then you see the integral is negative. Okay, that's all I want to show you from this link. Okay, we come back here. Okay, so this conclusion again, okay, you need to copy it. Okay, so you see here, okay, this area is on the right, on the right of x-axis, so it's positive. On the left of the x-axis, so it's negative, the integral. Okay, the integral. Okay, but same thing. Okay, when you are finding area, the final answer should be positive lah. Okay. So we come back here. Just now we have done B. Now we look at A. Okay, just now the B, okay, the area is on the right of the y-axis, therefore it's positive. Okay, now you look at the question A. Okay, the area here is on the left of the x-axis, of the y-axis. Therefore, okay, afterwards when you get the answer, it should be negative. Okay, then you write the last sentence. Okay, is positive. Now, this one you get negative, then you write the last sentence. Okay, make it positive. Okay, so how to do these questions? Okay, so same thing, you know, here is 1, here is 4. Okay, so lower limit is 1 and 4. Okay, and then both value you take from y-axis, so this is dy, so x dy. Okay, x dy. Okay, now same thing, I can't integrate x with respect to y. I got to change the x in terms of the y. Okay, how? It's from here. Okay, I have negative x is y squared. So x is negative y squared. Okay, so I change the x become negative y squared. Only I can start my integrations. Okay, so I integrate negative y squared, I get this. Okay, then substitute the 4, 1, I get negative. Okay, so last step, change the answer to positive. Okay, maybe we could try this. Okay, use a calculator. Okay, to check your final answer. Okay, but all this step you need you can't just from the calculator, you know, just give me this answer. No way cannot okay. So I want to show you this calculator. Someone say something? Yes, send through PDF PDF I just net photo only more. Is it okay? Net photo and then send through WhatsApp. Is it okay? Emma? Okay, okay. Come, we look at the calculator. Okay, this is a silver color calculator. I don't have the black color calculator. You know, they ask. There is some teacher. They are very good in all this technology. They teach us how to download the app. The app can call the app or not? Okay, into our laptop so that easily can show you. Okay, can you see the screen? Can you see the calculator?
Can see.
Huh? Can you see the calculator?
Can.
And okay, now I want to do this. Okay, I want to do this one. Okay, which is the question A. Okay, so means I want to get the answer negative 21 Okay, so I don't know how to do it or not try Okay, so you follow the step. Okay, but remember this is for you to check answer because you know why you need to check answer in this way is because this part always the student will make mistake. This part when you substitute the value I don't know somewhere somehow it will make a careless mistake. I don't know why. Okay, so it's very it's good actually for to use these tools. I mean for you to use your scientific calculator to double check your final answer. Okay, so we start with this. Okay, put in the integrations. Okay, this is a negative x squared dx they cannot have y the calculator they will read all everything in x. So you the y here all you change to x. Therefore, actually you are doing this negative x squared dx Okay, so you key in negative, this key. Okay, the x squared you have to ask your calculator to read it as alpha. Means not how to say not a number, it's a variable. After that, you have to replace it with the limit, the 1 and the 4. Okay, so you have put alpha. Okay, and then remember to close the apa tu to close this close bracket. Okay, if you don't close bracket they can't read it. Okay, and then x squared, so x squared. So now you have key in your functions. Okay, negative x squared into your calculator already. Okay, after that you just go back. Okay, to key in your limits. Okay, for those are using the black color one, I think you follow this step code. Okay, you can try lah. Okay, the upper limit is 4, so we key in 4. Okay, good, some more. Okay, lower limit is 1, so you key in 1. Okay, then you just press equal. Okay, make it 21 the answer. Okay, if you are using the silver color one, then you follow my step lah. If you are using other calculator, then you pandai, okay, cari sendiri ya. Okay, go and learn okay how to do it by using calculator to get the final answer. Okay, so this is for calculator. What's the time now? Okay, 52 already. Okay, I got 8 more minutes. Okay, I can show you one more example. Okay, then I will stop. Okay. Okay, this is the one. Okay, the diagram show the part of the curve. Okay, find the region of the shaded, the areas, sorry, find the area of the shaded region. Okay, so the same thing, you see here. Okay, this part is on the left of the y-axis. Okay, this one you will get negative. Okay, and then this part, okay, is on the right of the y-axis. So this one you will get positive. Okay, but here the same thing. I need this point, and this point. This point, no doubt lah, this is 0. Okay, I need the y-intercept. Okay, for me to get the y-intercept, I set x equal to 0. Okay, so x equal to 0. So y minus 2, y minus 5. Oh, the question actually very good, huh? They factorize sub for you already. So y equals to 0. Okay, y equals to 2 and y equals to 5. Therefore, this is 2 and this is 5. Okay, so for the integration 2 to 5 and 0 to 2, you separate. Okay, like just now. Now, okay, you see the A, for the A, you are getting positive. Okay, for the B, you are getting negative. Okay, afterwards, the B one you change back to positive and then change back to positive and then you add these two. Okay, then you get the final answer. Okay. Before that, okay, how to integrate? How to integrate? Okay, let's say we look at region A. Okay, region A from 0 to 2. From 0 to 2. The 0 to 2 you take from a y-axis. So this is dy. Okay, this is x. Okay, same thing. I can't integrate the x with respect to y. So you got to change the x in terms of the y. Okay, so from where you get? From here. Okay, so 0, 2. Okay, and then y. Okay, y minus 2, y minus 5. Okay, dx. Okay, this is how you get. Okay, after that, same thing. Okay, you cannot integrate this. You got to expand it. Okay, so after the expansion, you get this. Okay, when you have this, only you can start your integration. Okay, after that, substitute the point. Okay, so minutes. Whether I can ask you these questions. Okay, let us try. Okay, okay, I give chance to Aksa, Dashna, and Kritika. Are you here? Dashna not here. Kritika also not here. Okay, Aksa, I don't know whether you want to answer my questions. You are here or not, Aksa? It's okay when you feel like you want to answer me. Okay, you can type in the chat or you on the mic. You can cut the queue anytime that you like. Okay, so Lydia, maybe you can answer my questions. Okay, we do it together. These questions are. Okay, we look at 1A. Lydia, on your mic.
Yes, teacher.
Okay, look at 1A. You tell me how to find the area. Integrate what? Y
Wait.
dx, x dy. Or maybe you help me with the limit first. From what to what? Lydia? Hello, Lydia?
3x minus x squared plus 2 dx.
No, you answer my questions. Okay, the limit is from where to where? Lower limit
3
is
to
what?
0.
Upper limit?
3,
Lower
0.
limit is what?
0.
Okay, 0. Upper limit?
3.
3. Okay, before you tell me blah, 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 first, I want to ask you, this is integrate x dy or y dx?
Y dx.
Okay, y dx. Okay, because 0 and 3 you take from the x-axis, therefore is y dx. Okay, now you continue. Okay, substitute the y in terms of x. So what it should be?
Three x minus 2x. 3x minus x squared plus 2 dx.
Very good. Okay, thanks for your help. I think I cannot continue already. Only have 1 more minute. Okay lah, continue lah. Okay. Shahira here? I don't know whether y'all can do it very fast or not. Shahira here? The problem is you all got no mic, then type is very slow.
Yes, teacher.
Okay, very good. You got mic. Like, come. I want to give you 1 mark. Help me with the integrations. Fast, fast, fast.
3x squared over
Over
2
2. Okay, then.
minus x cubed over 3
Then
plus 2x.
plus 2x. Okay, thank you. Okay, 3, 0. Okay, then you'll just substitute. Okay, and then you will get the answer. Okay. So Shahira, I'll give you 1 mark also. Okay, I think that's all for today. Wait for a while. I take attendance and stop recording.